On April 20th, 2010, the Deepwater Horizon disaster changed the lives of millions living near the Gulf of Mexico, as well as the scientists who responded to the crisis. These are some of their stories, intimate portraits of research, innovation, discovery. Welcome, I'm Jim McNamee, editor of Dispatches from the Gulf, a series of documentaries, short videos, and podcasts. In today's podcast, Kristen Thyng will tell us about her work mapping ocean currents in the Gulf of Mexico. Dr. Thyng works at Texas A&M University, where she's put a background in physics and math to use, creating complex models of the Gulf.
My name is Kristen Thyng, and I'm an assistant research scientist at Texas A&M in oceanography. I've really enjoyed working on transport modeling of oil in the Texas and Louisiana shelf. It's given me a lot of opportunities to think about different problems, both from the physics perspective, which is in line with my background, and the application side, which is great because that's where we can end up really trying to help people and problems that come up. I came into this department to do work looking at transport modeling on the Texas and Louisiana shelf, not having done that before. So I've been able to really take a hold of this area of research for our group, developing an open source tool to look at these sorts of problems. And that's enabled me to look at a number of different problems from different perspectives in terms of where oil is going to go and why, and the physics underlying that.
Dr. Thyng uses complex models based on thousands of field measurements to run what are called drifters through possible ocean current scenarios. Essentially, these models let her make a very educated guess where a message in a bottle, or a patch of oil, would end up if you dropped it anywhere in the modeled area of the Gulf of Mexico.
My research group has a numerical model of the ocean currents on the Texas and Louisiana shelf. Using that model output, I can run numerical drifters in that model to look at if you put stuff in the water, where does it go? And you can essentially put something in and watch how it moves in space and time. The neat thing about being able to look at numerical drifters in a model is that you can very directly look at where stuff will go. And by stuff, I mean really a lot of different things. Anything that can be modeled, in this case, like material in the water, pollution in the water, tar balls from oil spills that sit just below the surface, things like this can all be modeled in this way, and it's a very natural way of seeing where this stuff will go. I do numerical simulations, and I spend a lot of time plotting them and looking at the plots, visualizing what's happening, both because I want to communicate those to other people and because I need to understand what's going on as well. And when I first look at them, I generally find that it's confusing and there's a lot of stuff going on and it's hard to tell. But the more I look at it, the more time I have to really start to pick out different patterns, then generally I'll be able to really see it myself, and then I'll spend more effort after that trying to see how to show it to other people, how to highlight what I'm seeing so that other people can see the same thing.
Today, thousands of scientists, oceanographers, chemists, engineers, biologists are all working together to develop newer and better ways to understand and ease the impact of oil spills. To learn more about their work, visit our webpage at dispatchesfromthegulf.com. Funding for this podcast was provided by a grant by the Gulf of Mexico Research Initiative. And thanks for listening.